We're going to go over some concepts you'll be expected to know when you take your 6.1 to 6.2 quiz. So for questions 1 through 4, we're going to use the equation f of x equals -4 sine of 3x plus pi over 4 minus 2 to answer some questions. So the first thing we know is what the period of the graph is. So you remember from your notes, the period comes from 2 pi over b. And in our equation, b is 3. So our period is going to be 2 pi over 3. Next, we want to know what the amplitude of the graph is. So the amplitude is the absolute value of A. And in this example, A is -4, and the absolute value of -4 is 4. So 4 is the amplitude. Next, we want to know what the vertical shift of the graph is. Vertical shift comes from D, and D is -2. So our vertical shift is -2. And lastly, we want to know what the phase shift of the graph is. And the phase shift is -c over b. So in this case, c is pi over 4. And as we previously know, b is 3. So we're going to get -pi over 4 over 3. Which we want to simplify, and we can rewrite it as -pi over 4 times 1/3, which is -pi over 12. So our phase shift is -pi over 12. So what we have done in these first 4 problems is identified the key pieces of information that can help us graph our function. So we know that we're going to fit the entire sine wave into a period of 2 pi over 3. We know we've shifted the graph down 2, which means once we shift our graph down 2, we apply the amplitude of 4. And to get our maximum, we move up 4, and our minimum, we move down 4 after we've shifted down 2. And lastly, we know the phase shift is -pi over 12, which means we take the entire sine wave and move it left by pi over 12 to get our final graph. So next in problem 5, we want to write the equation that would best represent the graph we have. So if we first have to decide between sine and cosine, and because my graph has started at 0, 0, the easiest equation to pick would be sine, since sine also starts at 0, 0. Next, we have to identify the amplitude period, and then any phase shifts or vertical shifts. So if we look on a regular sine graph, the amplitude is 1, but our graph has been stretched. It now reaches to 3 and -3, which tells us we have an amplitude of 3. Also, on a regular sine graph, the curve starts by going up, and our graph starts by going down. So it also tells us that it has been reflected. And then we also know that in a typical sine graph, the period is normally 2 pi. But if we look at our graph, we fit an entire sine wave in 2 pi over 3. So that tells us we have a period of 2 pi over 3. Now there is no phase shift or vertical shift in this graph. Because it starts at 0, 0 like a typical sine graph, there's no phase shift. And because our amplitude is the exact distance from 0, 0, there isn't a vertical shift either. So now we can identify the information to write a graph. So an amplitude of 3 and a reflection tells us that A is -3. Our period is typically 2 pi over B. And because we have 2 pi over 3, that tells us B is 3. So now we can write the equation of our graph. We have y equals -3 sine of 3x. Last example, we want to graph the equation g of x equals -2 cosine of 2x minus pi over 2 on our graph. And we want to graph at least one period of our cosine wave. So we're going to start by identifying all of our transformations. So we're going to start with the fact that there's a negative out front, which means it has been reflected. The 2 out in front tells us that A is 2. We know B is also 2 since that is the number in front of X. And we know that C is negative pi over 2. So these are going to help us determine the period and the phase shift for our graph. So if we start with the period, the period is 2 pi over b, and with b being 2, that gives us 2 pi over 2, which ends up giving us a period of pi. Next we look at the phase shift, which is negative c over b, which becomes negative pi over 2 over 2, which becomes pi over 2 over 2, which we can write as pi over 2 times 1/2, which becomes pi over 4. So because our phase shift is a positive number, that tells us our graph has been moved to the right by pi over 4. So when it comes to graphing our actual function, we want to create our table of values. So if we start with our x values, because we've been shifted to the right pi over 4, we don't actually want to start at pi over 4. We typically like to start at 0, and then we'll have pi over 4. And then starting at pi over 4, we then want to graph one period. And because the period is pi, I want to go in increments of pi over 4 until I have reached that period. So pi over 4, then pi over 2, 3 pi over 4, pi, and 5 pi over 4. So typically the cosine function, if I plug in 0, would start at 2, but because we've shifted to the right, 0 is actually going to give us 0. And then typically the first point would be a positive number, but because we have that negative in front, we're going to start at negative 2. Then pi over 2 will be 0, 3 pi over 4 will be 2, pi will be 0, and 5 pi over 4 will be negative 2. And now that we have all of our points, we can graph our cosine function. So we start at 0, 0. And then at pi over 4, we're going to have negative 2. At pi over 2, we'll be at 0. At 3 pi over 4, we'll be at positive 2. At pi, we will be at 0. And then lastly, at 5 pi over 4, we will be at negative 2. Now all that's left to do is connect our points. And we have a graph of our cosine function.